Good morning, everyone. Right, this session is an introduction for Exadata database machine, and also we can consider it as a demo for this. Let's start the session now. Hope Devi Prasad, Manjeet, and Pawan, I think it's audible and clear for you guys, right?
Yes.
Yes, sir.
Yes, sir.
Yeah, perfect. Good, great. Thank you. Okay, so let's start. Before we directly jump into the Exadata environment, what is Exadata and all those things? Uh, give me a minute. Kishore is joining. Fine. Okay, let's continue now. I hope like every one of you aware about the rack environment, correct? Because this training program, that's like a prerequisite, you must be already knowing the DBA part, plus also the rack. These two are minimum as prerequisites here, DBA plus rack, correct? Okay, now before we jump into the Exadata environment, let's see about, let me open a whiteboard here. Okay, this one. Let's see first about the rack. So most of the rack environments, what we see, right, how they are built. Any of you did an implementation on rack implementation or installations, guys? Anyone?
Yeah, done.
Okay,
Yeah, the great
Yes.
so
Yeah, we have.
right. So what happens that architecture is seems somewhat like this, correct? So you will be having a public network. There are multiple DB servers. These are like a multiple servers, which I mentioned on the top. And this is like a public network, a private network, and also another is what? A storage network, correct? The storage server. So like this, we say always like this is my node one, multiple nodes like a node one and node two. Minimum two nodes are required for building a rack, minimum two nodes. So you require two servers and storages. Okay, let's understand the rack architecture especially basically, because what is the purpose or a role of a rack design? What is the role of a rack design, guys? Anyone? Why we go for rack? Why we suggest for rack? What is it?
for
Purpose.
availability.
For perfect. High availability. High availability. Any customers who is looking for a high availability, right, around the clock, 24/7, they want their database to be available, accessible, whatever the scenario. The rack is the solution. And we see that most of the customers, they have the rack environment. They're using the rack environment, right? Yes, no doubt. And we all know about the rack and we work on the rack environment. Yes. But in the rack environment, what you have multiple DBs and again, multiple storages, even multiple storages. Why? Because when I say high availability, a design, it must be there across all the components. Across all the components, the high availability design should be there, required. Now, each and every layer, you must think about high availability. Now, why I'm telling about rack and high availability, this is also a part of our Exadata. Don't worry, guys. I'll take you to the Exadata later, but let's understand first the rack here. Now, to build this rack setup environment, right, there's a lot of challenges comes in picture. A lot of experience, a lot of knowledge is required in building these setups. It takes, right, days, weeks, and even months to build one setup. In my laptop, if I want to do, I can blindly go and do it. But if it is for any client, the client need to start from deciding the servers. Hey, which server should I go? Should I take IBM server? Should I take HP server? Should I go with a Dell server? Which one? And which storages should I use there? The storage server where we keep the data, right? Challenges, a lot of challenges comes up here. But before I go with that part again, let me just stick first with this diagram, what I kept here. I kept here multiple servers and multiple networks. You see the public network, private network, storage network, and also the storage. Now, one by one, let me just come up in this fast. If I look at the storage, storage is the one where we keep all our data, right? So storage is used to keep all our database files. Database files, what are those? Like my data files, generally I draw the lines like this, saying, okay, one is the system data file, say socks, undo, temp, and then users data files, whatever is there. Then redo log files, minimum two are required, and one is like a control file, minimum basically. Nothing but these are the data files or database. Now these database files, I'm just keeping it aside, they're actually stored in the storage server and into a disk, correct? Disk is the primary source. Disk is the primary source to store our data, data, permanent storage kind of thing. Yes, that's the medium here. So if I look into the server, right, the storage server contains multiple disks here like this, and these database files are kept into them, right? This is the way. So storage server contains all our database files. Then what will be there on our DB servers, guys? What is there we have in our database servers? We got our instances, instance one, instance two. Now these instances actually, right? These instances, they will be accessing the database on the storage, right? So multiple instances, multiple servers, multiple instances running on the DB servers, they access the data which is placed in the storage. Now the challenge that if anything happened to any of the disk here, might be one of the disk got failed, right? Damaged. Because these are all hardware components, hard disk, right? Any failure can happen. The disk might be crashed or failed or damaged or right went down, right? So then what should I do, guys? Tell me now. In case if one of the disk is gone, is my database instance can be running that without the disk, because might be that disk contains my system data file. Example, imagine if my system data file is not accessible, can I still run my instance and allow my users to work? Is it possible?
No.
No, right? No, we can't. So what we need to bring back the disk, right? Or replace the disk with a new disk, then restore the file from our backup, do the recovery and give it to it. So that is really a long scenario. No one recommends because there is a downtime here now. There is a downtime. If system file is lost, none of your instance, even the instance one or even instance two, node one or node two, both instances, they can't run without system file. Even you have a 10 node rack, 10 instances, 10 servers are there, but if the system file is missing, gone, no use. It's like a downtime, right? You need to perform restore, recovery and all. That is like a downtime. You need a downtime. Yes, to avoid this, what should I do, guys? Tell me now. What shall we do to avoid this? Because the disk
So
can
that
fail.
creates redundancy. Disk redundancy.
Right, disk redundancy. So we need to maintain a copy of that data into other disks. Other disks. That will be helpful. Okay, so then I got an idea. Hey, why can't I go with this kind of design? What is that? I'll take up these servers like this or the disks. This way in my storage. So I'm going to make two groups in the disks, two groups, and whatever data is written into the one set, the same copy gets mirrored into the another one. Mirrored into the another one. right? Yeah, this way. So by doing this way now, you have two copies of data, right, in two different set of disks. If one disk fails at any time, my database instances are still running, reading data from the another copy, because we are doing the mirroring between these disks. Agree? Yeah, mirroring between the disks. Two sets, I can say. Now, don't say, ask me a question raising that, hey, if both the disks are fail, then what? The disk 1 and disk 2 both got failed. That rarely happens, man. Generally, failing one disk failed, that is one fine. But again, even a rare scenario, it never happens every week or every month a disk is failing. No, never. Right? And two disks failed or all the disks are failed, right? That is again a rare scenario. Very rare. We basically plan from a single point of failure concept. What is single point of failure? That's one disk fail, then we should have to have a solution. I'll give a simple example, guys, here for everyone. Saying like I'm going for a family trip, a festival season and holidays. I'm planned for a long drive. I took my car with my family and I'm going for a vacation for 1 week, something kind of like, yeah. So when I'm taking my own car and driving, how many stepneys do I carry? I'm going in my own car. How many stepneys? Generally, we look at one stepney and make sure it is fine, good, go. Have you ever thought that if more than one tire got failed, like might be I have four tires, right? When I leave every car, right? Yes, so if all the four got failed, so I need four stepneys. Have you seen anyone carrying four stepneys anytime? If four tires got failed, punctured, right? No, never, nowhere even. Agree? Yes. Single point of failure. We all grown up driving the bikes and cars and everything right now. Have you ever faced that your two tires got punctured at the same time? Your bike, two tires are punctured. No, right? Rarely any of us might be, once only in the lifetime. That is a rare scenario. So that's why we always follow the single point of failure. For high availability, that is enough. That is enough. Single point of failure means at a time only one failure, like one disk got failed. Then that's why we are planning for a mirroring here between the two sets. I have another set of disks that will be helpful. Make sense? Is that clear? Improving the availability here, improving availability by doing a mirroring. The question comes up here, one more question someone is asking me, saying, Akal, if the storage server itself failed, then what? If the storage server itself got totally entirely failed, then what should be done? I'm losing both the disks here, correct? Possible? Yes or no?
Yes.
Yes, possibilities are there. Possibilities are there that your storage itself entirely got failed. So that's why it's also recommended that to better to have one more storage here. Better to have one more storage server, again with the same set of number of disks there too. And it's also recommended now that you better do the mirroring, right? Generally, we do the mirroring between the set of disks like this, right? But this is, it should not be like that. It should be like this one should be considered as one set, and these set of disks should be considered as another set, two sets, right? And let me do the mirroring between them like this, between these two sets of disks. So whatever data is written into set A, example, any content, let me name it as or refer it as a content, like what are the set of blocks are there, same will be mirrored into somewhere in another set in any disk. Here you got it. So what are the set of content, right? We write it example file B content here, and the same copy mirror will be there into another disk, another set. Getting my point? Because at a time, if one disk fail, I can still access my data from the another set, another disk. If one storage server got entirely failed, right, entirely failed, I can still access my data from my another storage server. Agree?
Yes, sir.
Yes, I can improve the availability at my storage. Now for doing this, right, there are multiple ways, because what we need multiple storages. We understood we require multiple storages, and we require the mirrorings like we have. When I say mirroring, nothing but these are achieved by RAID configurations. We need to do the RAID. Now, when we say RAID configurations, we have hardware-based RAIDs, hardware RAID configurations are there, and another is software RAIDs. Hardware RAID, nothing but, right, there is a RAID controller will be there, and that will take care of the mirroring. The one is a hardware RAID, another is a software RAID, and most of the cases we use the software RAID. We have a lot of softwares which will do this RAIDing part or nothing but mirroring part. Like volume managers are available. LVM we call logical volume managers at OS level, Linux, or right, any vendor like Windows or anything, they have each operating system guys, they have their own volume managers. Similar way, the Oracle is also having their own, right, software here called as an ASM. Correct? Using ASM, even you can do the mirroring. So using LVM or ASM, that's like these are the software components. You can go for what is this called RAID configuration. You can go for a RAID configuration. And what is what we can achieve by using the RAID here? The mirroring part, mirroring of data, mirroring of data. Yes, you can get it using software RAID or using the hardware based RAIDs, where I can do the mirroring like this between the set of disks within a storage or into different storages, and the different storages are recommended here. That's why if you want to have high availability, if you want high availability, what you need multiple storage servers here. What we need here? Multiple storage servers. Multiple storage servers are required. Is that clear, everyone? Yep.
Yes, sir.
Yeah. So this is one basic requirement or recommendation. You require multiple storages, storage 1, storage 2, and do the mirroring between them. So we see that at the storage level, the high availability was designed, high availability. Now coming to the DBs, yes, and the DB servers also we use a software. What is the software we use for high availability here? I'm just drawing the line like this here. What is the software we use here? That is called as the clusterware. Right? Cluster software, nothing but the clusterware we use here, clusterware. So using the clusterware, you are improving the availability on your instances, because in case if your instance fails, goes down any reason, they must be started automatically. You know, who will start up these instances and all? Might be your listener went down, you have a listener process. Generally, I'll draw the line like this, uh, right? A listener process or your instance. This is my instance. If it goes down, someone is responsible to bring it up. Who will do that one? My clusterware. Clusterware will be monitoring, right, all your components in your server, your listeners, your ASM instances, your disk groups, your database instances, everything is monitored by the clusterware in a node. Now, what clusterware will do? Basically, two tasks, guys. Main. What is that? In case if the listener is down, Who is going to bring it up, start it up again immediately? Cluster aware. If your instance goes down, who will start up? Cluster aware. If your disk group was unmounted any reason, who will try to start up? Cluster. Cluster is the one who is actually doing the restart of your services which are under monitoring. It is going to restart, restart, restart the service. That is a one, right? Cluster is responsible in restarting the services automatically. And again, based on the configuration also, like might be it is not starting up entirely down, even clusterware will try to start that particular service on the other node too. Like might be you configured some services you configured that service should be running. Let me say this is service, and the service should be running on this node one. But in any case, in any reason, like if the service goes down, I want the cluster way to start on the other node. Nothing but how this is actually started. That service is started on the other node. Can anyone tell me, guys? Is this node cluster is going to start it on the node two? No. The clusters are communicating each other. Correct? The clusters will communicate each other, and right, the notification messaging part is done by the cluster to the other node, and the other node cluster is responsible to bring up that particular service. Correct? Is
Yes.
that right? So how these are communicating? They are communicating over this network. We have a network. What is this network called as? What is this network? We call it, refer it as
Private
private
network.
network. So clusterwares requires a dedicated network for communication. My cluster need to communicate. We are using a dedicated network here, and the other node cluster will immediately start up your services on the other node. This concept is called as a failover. This concept is called as failover. So restarting of services or failover of the services are done by your clusterware. So his main job, primary job is to continuously monitor, but in case if it fail, it will restart on the same node or it might fail over to the other node, that particular service. And the service, nothing but it could be just a normal, the listener services or right, your ASM instance or anything, your database instances, disk groups or anything, right? They are monitored and they can be failed over. Correct? So clusterware is the software actually, which is giving me high availability, but just having cluster is not enough. You require multiple DB servers also there, and you require a private network too here, correct? Multiple servers, private network, cluster software. Yes, I'm able to achieve by all these things now. So we see that for storage, we have a storage network here. In the rack environment, we have a dedicated network for the storage access. We got a dedicated network for the private access, basically for the clusters communication, and a cache or cache fusion. I hope you all aware about the term cache fusion. We call our cache fusion, what do we call? Cache fusion. Cache fusion, yes, we require a private network there, right? Right, where your instance to instance data transfer will happen there. What is happening? Why it is used to transfer your data between instance to instance. It's a rack part actually. Yes. We require a private network. Then finally, we have one more network called public network, right? Because your applications, where it may be, they want to access, they will communicate to the nodes through this network. They can access the node one or they can access the node two, right? So all my clients, end users, they will use this network, private network for communication. So we are able to achieve the high availability. If you want high availability, guys, tell me now here one by one, what all we required? What all we require? We require multiple DB servers. Agree?
Yes, sir.
Multiple storage
Storage.
servers. What more? Plus, we also require, these are the hardware components. What about the software components? I'll remove the,
Cluster, sir.
yeah, we require the cluster here. We need the clusterware, nothing but cluster software. We also require the ASM also at the storage level for doing the mirroring, right? Yes. I see that for getting in high availability, we require multiple. It's like a hardware and software combination. So I can say hardware and software's combination. If you want high availability, we simply say, hey, please go for rack. Rack is the solution. Now, what is a rack actually? What is a rack? Rack is nothing but a combination of hardware and software where you require multiple servers, multiple storages, and softwares also. Okay, it's not done yet. What is that more? Now, any reason if the clients, if these are the clients here, if the clients are unable to access the node 1, why? Okay, let me a little bit maximize this. Yep. I'm just going to say that, hey, if this network card failed, then what? Possibilities are there because it's a hardware component. It can be, right, crashed or failed or anything damaged. In case if that network card failed, tell me guys, my application or end users, will they access or are they able to access the node 1?
No.
Node 1, yes. No, not possible. Right. The entire server, a huge server is not reachable to my end users, not reachable to my end users. So what should be done? Then tell me guys, what should be done? Anyone? Better to have one more network card here. Yeah, better to have one more network card. What happened? Yep. Better to have one more network card. So when I go with this multiple network cards, then how the design going to be in that case? How that design going to be? Let me remove these things first. Oh, okay. Okay, so when I go with multiple network cards like this, the design, right, will be different. So you'll be required here the switches here. So obviously there will be a switch. I'm just trying to put that switch and then write the connection 1 into one port, connection 2 is into another port. For same thing, I will go with the other side also. Connection 3, right, will go to one port and connection 4 will go to another port. If one port fail any reason, I should be able to communicate with the second port. Yes, agreed? Make sense? Clear, everyone?
Yes, sir.
High availability. If one port is not there, I should have one more port. Something like if you want to talk to me urgently, right? My phone got switched off or down. What do you need? Or might be that number is not working. So you need an alternate number to communicate with me. So you will try the other number and yes, you're able to reach me and you can communicate. If my phone itself completely dead, then I need, if I want to give high availability service for everyone, I should have to have one more phone with me. If the first phone is not working or not reachable, then if people can use or anyone can use immediately the second number and talk to me, or I can use my second phone to communicate. Right. So require multiple network ports here, right? Multiple network ports. If one port fail, as people should be able to access or communicate with the second one. But if you look into the server, as I said, like there are two network ports are there. Are we going to have two IPs then? Like might be some series. I'm using some series example, 192 series. If I keep here 192.168.10.10. The IP next. So are you going to keep 21 here and then 22 here? for each one a separate IP like this? No, I don't want. I don't want, because how the client will be communicating? He need to communicate with 21 every time. If 21 is not there, means the first network or card, then he should communicate with a 22. Well, this doesn't work well. So what can be done in this case? Now, don't give the IPs directly to those physical cards. These are the physical cards. What we do basically, yeah, we take these multiple cards and we group them. We're taking these multiple cards and we are grouping them into one virtual card. And we assign that IP here to the virtual card here, 21. Getting my point? Yeah. So my 21, when I say, yeah, the 21 actually contains multiple network cards there. Good. So that means the request can come up, right, and be sent through any network card here. This is called as grouping, bonding, trunking. Different vendors, operating systems, they use different terms here, right? We generally, it's nothing but a grouping multiple cards into one logical or virtual card. Grouping, bonding, trunking, we call as. That's what we do. Okay, so grouping, bonding, trunking, normally networking guys, they will be doing for this. Don't worry, it's not our job. They are very good into that. Let they do. But while doing even, right, even you can configure that, hey, one network card, right, I want it to be configured as active, and the another one, we want it as passive. The another one, we want it as passive. One is active, the another one is passive. What do you mean by this? One is active and a passive. That means all the traffic every time, right, will be sent through this network card. Right? All the traffic is basically sent through this network card. That means this network card is active round the clock, 24/7. In case if it failed, then only the passive will take the charge and then the communication will happen through this passive network card. High availability, same 21 you are able to reach. Earlier you were using a different network card, but now the another one, same 21. So this is active passive configuration, active passive configuration. And even you can even configure not only active passive, right? Even you can configure active also. You can even configure active. Both are active. That means my right requests are sent through both the network cards. So I'm using, all right, I'm using the high power here. Both network cards are used, and each network card, whatever the limit is there. So I'm getting the double the limit here of for my data transfer. And high availability is also there. If one network card fail, still I can communicate or access the same 21 same server with the second network card. There's nothing to be changed or defined at the application level, nothing. It is done, taken care here at the server. By doing the bonding, grouping, trunking, and the bonding can be done by active passive, that is normally by default kind of thing, and even active configuration that depends on the network card you are using, the drivers you are using, the method driver and all, they should be supportive. Then yeah, you can do active. Because why I'm saying this, because in older versions, it's the same architecture is there with the Exadata, man. There's nothing changed. In older versions, right, we used to have mostly active passive configurations, but slowly a lot of enhancements, developments are happened, and now most of the environments are all with active. So automatically you are getting double the bandwidth here, double the speed you got, plus high availability. So performance is improved here, plus availability is also improved. But the challenge comes up here. What is the challenge? Next challenge. The question, right? Saying, hey, if the what is this? A switch got failed. If the switch itself got failed, tell me, can I access my node 1 or node 2? Any of my instance can I access?
No. No.
Now we are ending up into again the same scenario. Availability, how can I improve? How can I improve? Yes, to have more availability now, you should, right, come up like this. You require multiple switches there. You require multiple switches. I think I have to, yeah, multiple switches, somewhat like this. And we need to redraw these lines because we need to come up with multiple switches here. That's what we understood. Then how the connection or communication is going to be. Now in this case, right, one connection from the node 1 is given on one switch and the second connection should be given on the second switch. Right, same thing, we will do it from the other node also. Each node, one connection is on one switch and the second connection is on the second. Then somewhat like this. Accessed. So we got multiple network cards here and even multiple switches. Make sense now? If one network card fail, can I still access the server or not? Right? Yes. And if one switch got failed, can I still access the server or not? Yes, why not? So you can, that request can come up here like this and it can go through this switch and it can communicate or access the node 1 or even the node 2. Agree? Yes, high availability now. Seems like this kind of design we need it at each layer, means the private network, as on the private network also we need the similar kind of designs. Multiple network cards and multiple switches. So what I will do here now, very simple, I'll go with multiple cards here. I'll put it here. First, let me put multiple switches here. Yeah, this is better. Then one connection through one switch. The second connection is through the second switch. Right? I think I have to do the same with my storage also. Storage network entirely. Yes. Correct. We need that. So let me remove it everything here first, because my storage is also contains, but we need multiple, what is that? Controllers. Multiple controllers on the storage is required. So we need multiple switches even. So these are the switches I can say. Let me say this is my switch 1, switch 2. And the storage level also you got multiple, what we call this one connection is one, second connection is given to the second switch. One connection is on the one switch, second connection from the storage to the second switch. Same thing from the storage also, one connection from the storage is given onto the one switch, second connection on the second switch. Same thing here, one on the switch 1 and the second one will go to the switch 2. And also mostly we prefer to do the bonding event, right on this case. So if one card fail at the storage level, even one storage card fail, still I can communicate. One switch fail, still I can communicate. Anywhere at the storage server level might be one card failed. Any, right? Let me keep it on the node 1 side better. Still it can access. Agree? Right. We are able to achieve this high availability here. We are able to achieve this high availability, right, by doing this part. Right, by doing this, yes, we are able to achieve the high availability. Agree, everyone? Any doubts in this? Any questions?
No, sir.
Good, thank you. Okay, let me draw those lines again because it's not fitting in the screen. So let me just take it up. Yeah, like this. This is what we see basically in our rack architecture. Right. Improving high availability. Now, perfect. So I see that we need multiple DB servers, multiple storages, and what more we require, guys? What more we require? We require multiple network cards and also multiple,
Switches.
and also we require multiple switches. Multiple switches. Yes. Correct. So I see that rack is a combination of hardware components and software components, right? And by doing all these configurations, we are building the rack setup or environment, which is giving me high availability. And this is what we see everywhere. Not an issue. It's there everywhere. Every customer is using rack high available design, and we all know about it. But it's not that easy to build the setup. You see on the left side, all the image, whole image. It's not that easy. Why? What are the challenges here? There are so many challenges are there. One, for building the setup itself, right? Because the servers are from different vendors, the storages are from different vendors. That's the first big challenge. We have servers from Dell, HP, IBM, right? Many vendors. Same storages also we have from different vendors. Earlier used to be there is a leader called EMC, right? Now it became Dell, NetApp, right? What more? Hitachi, they have the storages. Dell, they have the storages, and there are so many vendors are there. So when I buy a server from HP and I'm using a storage from, right, Hitachi, imagine compatibility issues, hardware compatibilities, software compatibilities, drivers compatibilities, correct? Firmware's compatibility, firmware, again, yeah, issues. The versions might not be compatible. So that's why for building this setup, the hardware team, the storage teams, right? The sysadmin teams, they really work hard before we start our implementation. They really work hard even for days or weeks or even a month to make this setup ready for you so that you can join simply and start your installation. Correct? Agree? It takes time. Can it be done within a day? Within a day? No. So building the setup, the hardware layer and the software's layer, it's a really challenging part here because they're all from different vendors. A lot of difficulties are there, the versions, models and all, and might be the performance issues can come up. You need to fine tune your DB servers, fine tune your storage servers, network layers, everything to give you the best performance. A lot of expertise is required here, expertise. It takes time again even to build these setups. That is the one thing. Building a setup itself is not easy. One big challenge. Now that is the one. Once it got builded, that's good. It's running, and many customers as they got the high availability solution. Now there is one more term people are looking at because once they achieve the high availability, wow, great. We have a rack setup. They're really happy. They proudly say, yes, we have rack. We have 2 node. We have 4 node. We have 8 node rack. That's really great. But the next challenge for them, those customers, is what they're looking at. What is this term? Performance, right? The performance is the next they are looking at. The rack environments, are they going to give you delivery for best performance? No. We DBAs all really work hard very much on the rack environments to get the best performance as possible. But again, limitations are there, limitations. We can't do from our end, right? Hardware limitations are there, especially the hardware limitations, we can say, the programming limitations, right? Like if a database related to data warehouse kind of thing or OLTP is what it may be, if a full table scan need to be done, just imagine huge table has to be read, millions of records in them. It takes hours and hours to read all the data, put it in the buffer cache. Again, memory concerns, right? IO concerns. Put it everything, the full table scan means the entire table data should be loaded into the memory. Huge table data from the storage must be loaded into the memory, right? Loaded into the memory, into the where? Memory area, then scan and then give it to you. Now, loading all this data, they require a lot of IO bandwidth. So now the challenge comes up here with the IOs on the storage network. So I can't do, but the limitations, hardware level, components level, right? Program level, because application was poorly designed and it has to go through a lot of full table scans. We can't do anything in that. So a lot of challenges are there in this, and it's really very difficult to gain the high availability. Gain high availability. Sorry, not high availability. What is that next term? Performance. Oracle says, don't worry, man. We have a solution for you. What is that? We have a solution. Let me better take a copy of this one itself as it is. Let me better take a copy of this. Oracle says, hey, you come to this site. I will give you the performance. How? By using Exadata here. Exadata also contains the same thing here, man. See, that's why I took the same diagram here. Nothing changed. I need to do small changes here. That's all. I'll do small changes in this one by one. Okay, so what it contains, Exadata? Exadata contains the multiple DB servers and also multiple storage servers, because that is what basically required for high availability. Exadata also contains multiple DBs, multiple storages, right? Yep. Multiple DBs and multiple storages, same thing. Same multiple switches also, you got it here. Multiple network cards. Okay, let it be that one. Same thing with the cluster web job, no need to worry, right? What are the challenges we see in our rack environment, the other side, right? All those, most of them are taken care here very well, a nice way. They're taken care into this. In Exadata environment, I'm saying that I'm not mentioning the Exadata diagram exactly, but I'm telling you the same components. Like you will have DB servers and you will also have the storage servers and also a storage network, right, is required between them, correct, for data transfer. If I look at my rack environment, in the rack environment, basically the storage networks are, what is that we use basically, guys? Anyone? Anyone? What is the storage network you're using? Might be you use iSCSI or Fiber FC, correct? The storage network, mostly iSCSI or FC network. We'll have FC, fiber controllers here, fiber switches are there. What is the maximum speed they can deliver you, right? Maximum, the controllers. It is 14 gigabits per second. 14 or 16 gigabits somewhere. I think so. 16, I hope. 14 or 16, guys, leave it. Okay, 16 gigabits, bits again, not bytes, always remember, it's bits per second, per second. That is the speed my FC maximum it can deliver, fiber. And if I look at the private and public network, the public networks are normally Ethernet ports. These are Ethernet, right? NIC cards, Ethernet NIC, network interface cards, NIC cards. Normal Ethernet port. It could be 1 gigabit or 10 gigabit Ethernet ports. Coming to the private network, yeah, you have a choice. You can go with Ethernet, or even you can go with FC here. It's all your choice, right? Yes. So public and private, mostly they can use Ethernet, right? Storage must be FC or iSCSI to access the storage servers, the SAN architecture, what we call, right, with the speeds. Now coming to the Exadata server, in older versions like X6, X7, X6 and X7, we were using InfiniBand. In old, from starting from very old, X3 onwards, right? Before that even, we have InfiniBand here, which is giving us 40 gigabits per second. Wow, more than a double, correct. There it is 16 gigabits. Now I got 40 gigabits, more bandwidth here with InfiniBand. Agree? Right. And in Exadata, we don't have this private network. The private network, I'll just keep it here. I'll keep it here better. Here itself. Or I'll merge with this. Means we don't have a separate dedicated network in Exadata. No, my clusterware uses the same InfiniBand for private network. See here, private nothing but node to node communication. Yes, it can be done here like this. Simple. Same network is used for private communication and also for storage communication. So we have only two networks. One is public network. The another is a private or storage network. Private and storage network, I can say. Make sense? Right. We are using the ASM for mirroring at the storage, and also you will have the cluster softwares on the DB servers. Cluster on the DB servers. Older versions, it was InfiniBand. Now the challenge is first thing that the servers, the DB servers and the storage servers, both are provided by Oracle now. Oracle is giving you the servers. You don't need to buy from anyone else. No, Oracle is giving you the DBs and storages, right? The hardware, the softwares in them, the drivers, the firmwares, everything is designed by the Oracle. Everything seems like under one umbrella. So obviously these servers, as they are designed for Exadata purpose, the DBs and storages, you don't need to do any additional configurations there because they are designed for Exadata purpose and they are customized even, they are properly fine-tuned even, and they're readily available to use. Simply readily available means you just like you take your mobile phone, when you buy a new mobile phone, what you do? Just few minutes you spend on like boot up, starting up and entering few basic details, and now your mobile is ready to use. Right? You're not installing any software, it's ready to use kind of thing. Same like here in Exadata. From the day one itself, you can start implementing your rack in that. You don't need to wait days and months here. You don't need that much of lot of expertise here. Yes, it's easily done here because all this, the DBs, the storages, the switches, everything, they are purely designed from Exadata point of view, database point of view. They are compatible to each other, the hardware, the software compatibilities, firmwares, drivers, everything is taken care by Oracle and given to you as one machine. All these are kept in one single box and get delivered to you. One single box. Right? And now this box is called as Exadata database machine. Exadata database machine is not the DB server or storage servers. No, Exadata database machine is the box, actually I can say, right, which contains all the things like your DBs, storages, switches, everything in there. Make sense, guys, now? And this gives you more advantage and more benefits. Oracle has introduced it's not just like having all the servers. No. There are many more other features they introduced here. Many more features and a lot of features at the storage level, like Smart Scan. One of the feature is Smart Scan. Right? Yes. You also have hybrid compression, hybrid columnar compression at the storage level to compress your data up to 10 times. Up to 10 times the compression means 100 GB data can be compressed to just 10 GB or even less than that. Up to 50x it can go. Wow. Up to 50x, 50 times you can reduce. Huge compression ratios are there. Smart scan, right? Another one, another feature, smart scan. We have flash drives also available. We call it as a flash cache. You can use the flash drive as a flash cache, or flash, yeah, cache. Flash drives. Now, what is flash drives? Anyone can just highlight on that? Update me. What is the flash drive here means?
It's kind of RAM, like faster accessible data.
It's not RAM actually. RAM is super fast. There's nothing more than RAM. First thing understand, guys.
The
RAM is the
memory structure.
fastest one.
Memory structure.
RAM is a fast. No, it's not a
It's a
memory
memory
structure.
structure.
It is a hardware component. I'm telling about the flash drive. Hey, flash drive we use, right? Every day pen drive.
Yes,
Just
it's kind of
USB pen drive. We call it a flash drive even, right? Yes, that flash drives. It's a small component in the pen drive. A small chip is there on which the data is stored. The bigger one, right? We call it as an SSDs. Correct? Yes, no?
correct.
Yeah, the bigger one SSDs. SSDs. Nowadays the trend is going on with the SSDs. Who like to have the hard disk? No. Hard disks are slowly getting aged out, right? But they are not yet out because hard disks are hard disks. They're reliable. SSDs is a new technology. We don't know about it, right? Until we face some fresh crashes, right? We don't know what kind of failures can happen, how to recover and all. It might take time for the technology to be evolved everywhere. But yes, SSD is another, the latest generation requirement. SSDs, flash drives. So SSDs are actually used here. Remember, SSDs are used here to configure it as a flash cache. Plus, we also have one more layer, one more component. We got it here. One more component, high-speed component. See, one is the hard disk. Let's say these are the hard disks. SSDs are faster than hard disks, right? And from the SSDs also, there's one more component, right? That is much more faster than SSDs, much more faster than SSDs. And then we got one more component, RAM. We all know about the RAM. RAM is the fastest one. As they are placed, and those SSDs are used as a flash cache here. SSDs are used as a flash cache. Huge cache, like buffer cache, how you have in the server. We use buffer cache in the server. Let's say this is my buffer cache or SGA. We use RAM for that. And here the flash cache at the storage, we use SSDs. Simple. All the frequent access data, we'll always try to keep it in the buffer cache to avoid the IO. And accessing RAM and reading buffer cache is 1,000 times faster than reading from disk. Agree? Same way, if the data is not available in the buffer cache, obviously the IO request will be sent to the storage. And if the data is available in SSDs, that is much more better compared to the hard disk. Again, flash cache is also a temporary area, right? It's like a buffer. How we are using buffer cache here, using the RAM, same way flash cache using the SSDs. But permanent storage is my hard disk. Terabytes and petabytes of data, you can keep it there. We got the InfiniBand earlier. Now we got another new network here. I'll be showing you that in the slide. And plus we can have one more feature on the storage that is called IORM. IORM. We have one more feature on the storages called as a storage indexes. Storage indexes. See that? A lot of features are coming up here on the storage side. Yes, a lot of features introduced to give you the best IO. World-class IOs. Perfect, man. And this is actually improving the performance of your environment. Anyhow, we have a rack architecture, so high availability is given to you already there, and also performance guaranteed with Exadata. Let me just go with a few slides here. Any of most of the part we understood. This is our database machine, the box, the one which I told you. We call it as a rack, RACK rack, RACK rack. The box, right? The cabinet or the box complete entirely contains so many servers. So these are my DB servers. These are the DB servers, and these are the storage servers. Storage servers are there in the top and bottom side. So right after that, you see the DB servers, and then finally you will see the switches. Now we got RDMA switches here. RDMA, that is actually ROCE we call RDMA over converged Ethernet, ROCE network, which is actually giving you 100 gigabits of network. 100 gigabits. If I go back here, now we are getting, what is that, guys? Tell me. RDMA with 100 gigabits per second speed. Per second. Wow. RDMA. Introduced newly. In older versions, yes, we were having InfiniBand, but this has double or more than double. 2.5 times it has increased the bandwidth here because of this network, right? So this is my database machine, which consists of DB servers here, DB servers store. So sorry, these are the DB servers. These two are DB servers layers. These are the storage servers, and these are the switches in between. Make sense? Everything in one box. They're giving you as database machine. Over a period of time, you see that the innovation happens starting with a V1, V2. Basically, these are designed on HP servers. At that time, Oracle used to tie up with HPs, because I started giving trainings with X2 model. We did the training for X2, and then X3, X6. The trainings are going on as we are with the Oracle long time. I was with them, right? I did training programs from so many versions, starting with X2 onwards, very old, right? So what is the difference in X2, X3, X4, X5, X6, X7, X8, X8M, X9 going on? See that two things will be there. If I look at this architecture, right? Okay. What is Exadata contains? Again, same thing. Exadata contains hardware components, correct? Hardware and what? Software. Not only these softwares, in Exadata, you have Exadata software also. There's one more software comes up in Exadata, that is we call it as an Exadata software. So two mainly, if you highlight, one is the hardware, another is software. There's a lot of improvements happens in them, hardware and softwares. Currently, I'm using OnePlus phone. I'll give simple example. Earlier, I was using OnePlus 6, and now I have, I think, OnePlus 9, I hope. Yep. What is the difference now? Not much difference, correct? Or if you say OnePlus 6, OnePlus 7, or OnePlus 8, OnePlus 9, any big difference? What are the latest versions you get, which you've seen already 6 months back? Any big differences in them? Not much. What will be the difference? Guys, can you tell me? Mostly the CPU. They'll say we are giving you the latest CPU, right? Hardware level. Might be some memory got added up here. In older mobile, I used to have 128 GB with 6 GB RAM. And I think now I have 12 GB with 126, 256 something. CPU and memory. The CPU model has also got changed, because that OnePlus 6, I got it 2 years back and 3 years back, 2 years older. So obviously it contains the older CPU now as per today. But that time when I got that one, at that time, that was the latest CPU in that one, the model. Now, whatever I get it, that I get it with the latest CPU, because the CPU, right? Who is that vendor? Snapdragon, I think, right? In the mobiles, yeah, MediaTek and Snapdragon, they are the ones who are actually designing the CPUs. Every quarter, every month, they are coming up with a new model, and those models are used in the latest phones. And the guys will say, hey, take up this new version which contains the latest CPU. Softwares are mostly same. I was using Android 10 or 11 at that time. I'm hardly using Android 11, or now I think I'm using 12. So you see that the improvement in the hardware and software, and they call it with a new name, OnePlus 8 or OnePlus 9. But the remaining most of the features, 90% features are same. Camera could be the same, right? The applications are same mostly. Yes or no, guys? Tell me. Most of them, guys, 90% everything is same. That's what happened in the same versions also. Why? Because, right, last year they launched example X7, right? They can't say that's a same X7, they can't sell it for next 2-3 years because this contains hardware and software. Remember, and again, it contains hardware and software. If it is only a software, I can give you a patch like database we were using for so many years. I'm using 12c version 12.2, then we got 12.202, 12.204, 12.206 in a year or 2 years or 3 years, right? Yes, we upgraded the software point of view, because still now we are as a DBA, we are dealing with only the software. Fine, you can just upgrade, patch, upgrade, done. Updates are done and the software becomes latest. But what about the hardware? You can't change the component. You have to change the server itself completely, right? That's why they need to come up with a new server saying, hey, X8, what is there new in that one? We have new hardware in that with the latest CPU available now. Again, X8M, we are giving you more technology and new hardware again in that. X6, you can better compare with X6 and X8 or X8M. Keep that out. X7. You can better use X6 and X8 comparison plus X8M. This will make you understand, because this was introduced somewhere around 2016 and this is we got it somewhere around 2019 after 3 years nearly. What is the difference? You see that one, all the components, major components like a CPU, what is the maximum memory they support? Flash cache, that's nothing but flash drives available, the disk storage, network fabrics, Ethernet, maximum IOs and scan rates in GBs and MBs. Okay, if you look at the CPUs, here you got 352. We don't need the older models because older obviously they will be lower. You see that? A lot of improvement happened. We got totally nearly 352 CPU cores you can get. Here you got 384 more. Maximum memory 12 terabytes. It's supported. You see that all these versions are not 12 terabyte. But if you go previous, it is only just, that is GBs, right? 6 TB somewhere around. 6 TB X5, it became 12 terabyte and it's going on. That's really big, huge, man, 12 terabytes. And if you look at the flash drives here in this older, 89 terabytes of flash drive is given, terabytes. And here they got 179, around 180, I can say, but it got improved now. You see all these versions, they have 356, 358 terabytes of flash drive. Improved, yes. Disk storage even, you see that in older version, it's like 1 terabyte, 1 point something terabytes. Now you got X6, you got same, but after that it got increased into petabytes. You see that one, petabytes, 2.35, X8 and X8M. Storage capacity was increased here compared to X6 and X5 models. Network fabric, you see that 40 gigabits from all these things, InfiniBand is used, 40 gigabits till here, InfiniBand, yes. And now you got how much? 100, that is in X8M, X8M you got. Ethernet, again, Ethernet network, gigabits speed, bandwidth. You see that 400 is available till X6. It was doubled automatically to 800 now. Maximum scan rates, you see in X5, X6, that's around 300, 260 to 300. And now you got, wow, nearly 560 gigabits, GBs that man, GBs of scan you can do. Plus IOs, around 5.6, right? Million IOs we are doing, we're talking about million IOs. And now you see 16 million IOs, nowhere comparable with X6 now. Agree, guys? These are all hardware components. You see on the left side, all these are what? Hardware. These are all related to the hardware which gives you the best performance. Correct? Hardware. The same way the softwares, but software remains the same most of the case. Example, in X6 might be I'm using 12C version. 12C Exadata software version. All right. In X8 also you might have, X8 also you can have 12C version. Software. My old laptop, I can have Windows 7, I can have Windows 10 also. I can even go with Windows XP. Older one. Might be the latest doesn't support the older versions. I can't take the latest laptop and install Windows XP. It won't support you. Try that one. Windows 7 also many laptops, they won't support latest. Compatibility issues comes up. But going forward, yes, it supports. Your X6 server even supports your X8, right? What is it? Exadata version 12C or 19C versions as they are supported. 12C or 19C. Yes. Software changes, hardware changes. That's what we see especially, right, in X8 or X8M compared to the older versions. Software and hardware changes, and there's a huge improvement you see in this X8 and X8M here compared to the older models, right? What we're going to cover up in this training, we got like introduction to Exadata. I hope you understood a lot of things about Exadata. Now basic part we'll be going with sessions like understanding each and every hardware components, the relation between them, how they communicate, how they work, what are the versions, what are the models, designs, everything. Right, we'll also discuss about the RDMA, which was newly introduced here, the network topology, network architecture topology, how multiple machines are communicated, connected, the software architecture, what softwares we got it, versions we got it, what components we have, how they communicate, again, all these parts. Then the features like storage index, hybrid kernel compression, flash cache, another one, persistent memory, PMEM is another one, right? Persistent memory is also another new feature in Excite. So this RDMA and PME, these are the two main new features here. Anyhow, the hardware is also part of it. Excite. In-memory columnar caching, another one. Exafusion direct-to-wire, IORM, IO resource management, we call this another feature we have. How the initial setups are done, right? Storage server administration, smart scan features, consolidation, migrating databases to database machine, how it can be done. Bulk data loading, database machine monitoring part. Coming to the monitoring, what are the monitoring, different tools are there. Entire database machine monitoring like your DB, storages, switches, everything, how it can be done. Backup and recovery concepts on the Exadata machine, maintenance tasks on the Exadata machine, patching part, right? And also some additional topics. They're all covered up in this training program. It's nearly 14 days of training actually. And the good thing that with this training, you will get a hands-on event on our environment. We'll be providing an environment. It is similar to like this, where you will see that multiple DB servers, like you will get 2 DB servers, and also you will get minimum 2 storage servers, minimum 2 required, right? For high availability kind of thing, yes. Where already the clusterware was installed, the database instances are running, correct? Yes. And we will do a lot of practices on Exadata features and components, flash cache, IORM, storage indexes, hybrid compression, right? All these things, features, we do that one. See, implementing, how this implementation is done, that no one will ask you and no one will ask you to do that one also, because they're actually done. That implementation is totally different. That comes up under the initial configuration, how the initial setup is done. These setups in the laptops, many people, they ask me like, hey, can you help us to build it in a laptop or anything? Don't need, man. That's actually not needed, right? This is not like a rack installation that I need a rack environment so that I can learn and I can do it somewhere else. No, it's not recommended even. Oracle is not providing any documentation on that. You know that. There's no help, no support from even Oracle how to build, right? And the many people, they provide you the very old version, even like 11G version, they will be giving you with just only a storage server, how to build our, right, providing a VM for the storage server to run some of the commands related to the storage. That storage server will help you only to just do only this one practice, storage server administration. What are the commands are there, utilities are there, how to run, how to configure, only that part. But all these things like a smart scan, right, consolidation options, we have backup and recovery tasks are there, some of them. We have IORM, right, initial configuration, many more, hybrid compression, storage indexes. This is all, you can't do it on that one, only one storage. You require this kind of setup where you have multiple DBs and multiple storages, right? Architecture, complete architecture. This will be helping you. So that's what we are going to provide you the lab environment to, right, for doing your practices, right? So this is what we got in this session, guys, in this session. Any questions, anyone? Any questions? Any doubts? Let me know.